Good morning. Welcome to algebra class. From this week, our lesson is about fraction operations. This is from 6-6, textbook pages 390 to 404. Before we start, I want you to prepare the following: your algebra textbook, your pen, and your copybook. Before we start, I want you to watch this video.
Let's find f plus g of x and then state the domain. Well, here we've been given two functions, f of x and g of x. And we've been asked to find this, f plus g of x. Well, what is that?
Well, f plus g of x means that all we need to do is take our two functions and add them together.
F plus g of x is the same thing as f of x plus g of x. So here, we're just adding polynomials together. And that's something we know how to do.
So, to find f plus g of x, we need to add our two given functions together.
Taking a look at our functions, we have f of x. Well, here we have a polynomial with degree 1. That's a linear function. If we take a look at g of x, we see a polynomial with degree 2. That's a quadratic function. If we have a linear function and a quadratic function, those are just polynomials. So we can add those together.
So let's go ahead and find f of x plus g of x. So we take f of x, which is 2x minus 6, and we add g of x, which is 2x squared minus 5x minus 3.
Perfect. Now, in order to get our final answer,
we need to simplify what we have. And we're adding these functions together.
that means we can simply drop these parentheses.
So we get 2x minus 6 plus 2x squared minus 5x minus 3.
Here we have some like terms, so let's combine them together.
And to make combining even easier, let's rearrange things so that like terms are next to one another. So we'll take 2x squared, then we'll add 2x, then we'll subtract 5x, then we'll subtract 6, and then subtract 3.
Remember to account for all the terms and keep the sign of each term with it. Now let's go ahead and combine like terms.
2x squared doesn't have any like terms, so we can just rewrite it. 2x minus 5x is minus 3x, and minus 6 minus 3 is minus 9. So this is the new polynomial that we get. This is f plus g of x. So now we have
our two original functions added together. So now all we need to do to finish up this problem
is to find the domain of our new function.
Remember, the domain is the set of x values that a function can have. And to help us find the domain of our new function, let's first find the domain of each of our original functions. So let's go ahead and find the domain of f of x. Well, taking a look at the function f of x, we could plug in any x value into that function.
So the domain of f of x is all real numbers.
Perfect.
Now let's go ahead and find the domain of our other original function, g of x.
Taking a look at g of x, we can also plug in any x value into that function.
So the domain of g of x is also all real numbers. Now let's go ahead and find the domain of f plus g of x.
When we're adding functions together, like we are here, the domain is the set of all the numbers that are in both of the domains of the original functions. So, we need to find out what numbers are in both of the original domains. Well, both of the original domains are all real numbers.
So, that means the domain of f plus g of x is also all real numbers.
So now we have taken our two original functions and found f plus g of x.
In this problem, you will add and subtract functions. Let the function f of x equal 4 times x plus 7, and the function g of x equal the square root of x plus x. What are f plus g and f minus g, and their domains? First, find the function f plus g of x. Write the definition of f plus g of x. Substitute for f of x and g of x. Combine like terms. The result is 5 times x plus the square root of x plus 7. Next, find the function f minus g of x. Write the definition of f minus g of x. Substitute for f of x and g of x. Combine like terms. The result is 3 times x minus the square root of x plus 7. The domain of f is the set of all real numbers. What determines the domain of g? The values of x that result in defined.
Got it 1. Let f of x is equal to 2x squared plus 8, and g of x is equal to x minus 3. What are f plus g and f minus g, and their domains? I'll give you 10 seconds to answer this question. Timer starts now.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. The answer is 2x squared minus x plus 11. First, we need to find f plus g. So f plus g of x is equal to f of x plus g of x. Then substitute. F of x is 2x squared plus 8. G of x is x minus 3. So we have 2x squared plus 8 plus x minus 3. Next, combine like terms. So we have 2x squared plus x plus 5. So where did we get 5? We have 8 minus 3. So the answer for f plus g of x is equal to 2x squared plus x plus 5. How about for f minus g of x? That is equal to 2x squared minus x plus 11. So we have the solution f of x minus g of x. We need to substitute first. F of x again is 2x squared plus 8. And g of x is x minus 3. Then substitute and simplify. 2x squared plus 8 minus x minus 3 is equal to 2x squared minus x plus 11. The domain of f is the set of all real numbers, and the domain of g is the set of all real numbers. And the domain of both f plus g and f minus g is the set of all real numbers.
In this problem, you will multiply and divide functions. Let f of x equal x squared minus 9 and g of x equal x plus 3. What are the functions f times g and f divided by g and their domains? First, multiply the two functions. The function f times g of x equals f of x times g of x. Substitute x squared minus 9 for f of x. and substitute x plus 3 for g of x. Then multiply. So the function f times g is x cubed plus 3 times x squared minus 9 times x minus 27. Now divide the two functions. The function f divided by g of x equals f of x divided by g of x. Substitute x squared minus 9 for f of x. Then substitute x plus 3 for g of x. Now factor. Remember, division by 0 is undefined, so any value of x that makes the denominator equal to 0 is excluded. The function is undefined where x plus 3 equals 0, or x equals negative 3. Remove the common factor x plus 3. So the function f divided by g is x minus 3 where x does not equal negative 3. The domain of both f and g is the set of real numbers, so the domain of f times g is also the set of real numbers. Is the domain of f divided by g the domain of x minus 3? No. The fraction can only be simplified and the function is only defined when g of x is not equal to 0. The domain of f divided by g is the set of all real numbers except x equals negative 3, because g of negative 3 equals 0. The domain of f divided by g requires that you consider the 0 denominator in the original expression for f of x divided by g of x, despite the fact that the simplified form has the domain of all real numbers.
Experiment number 2. Let f of x is equal to 3x squared minus 11x minus 4, and g of x is equal to 3x plus 1. What are f times g and f divided by g and their domains? I'll give you 10 seconds to answer this question. Timer starts now.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. The answer is, for f times g of x, that is equal to 9x cubed minus 30x squared minus 23x minus 4. How about for f divided by g, or f over g? And that is equal to x minus 4. And x should not be equal to negative 1 over 3. Very good. Next,